Hey guys, welcome to lesson 1.3. If you're following along in your textbook, I am looking on page 22. This is your online textbook that hopefully you will be able to find. All right, so today we're talking about precision and accuracy in calculations. And one way to talk about precision and accuracy is to identify significant digits. So before we look at some examples to answer, let's go over the rules for these significant digits. All right, so the first rule is all non-zero digits are significant. So that's an easy one. So you can see two examples here. This one has a decimal, this one does not, but all of these are significant because there's no zeros involved. All right, the next rule, zeros between two other significant digits are significant. So for example, 305 has three significant digits because the zero is important for that to be 305. Also, where this is 0.6 and it has these zeros and 8, again, because the zeros are in between two significant digits, those are important. So that one has 6 significant digits. All right, zeros at the end of a number to the right of a decimal point are significant. So if it's on the right side of the decimal point here, these are considered significant digits. So that's like talking about your decimal places here. So this one would have 1, 2, 3, 4, 5. Even though if you drop those off, it's not going to change the value of the number, but because it's like a placeholder, those are considered significant digits. All right, and this one right here has 1, 2, 3, 4 significant digits. All right, zeros to the left of the first non-zero digit in a decimal between -1 and 1 are not significant. All right, so this right here, the decimal place has 3 zeros before the 1 and the 5. Only the 1 and the 5 are considered significant. And here, 9108, this one has 4 significant digits. Zeros at the end of a number without a decimal are assumed to be not significant. All right, so this one would be 507. Instead of 50,700, this one's saying that it only has 3 significant digits. And this last number here only has 2 significant digits. Out of all of the rules to remember, I feel like this last rule is the hardest, maybe the most confusing, kind of the hardest to remember because you think like it needs those zeros to make that number. But we're going to look at how if you change some of these to scientific notation and otherwise, that it will hopefully make a little bit more sense. All right, so let's look at some examples here. All right, it says, so identify the number of significant digits. So this one has no zeros, which means all of those are significant. So we can type in a 3 for 3 significant digits. This one here only has 1 significant digit because of the 0 here is to the left of that number. So it's between it's between -1 and 1. That goes back to one of the rules we looked at. This one has a 0, but it's between 2 other significant zeros, so that counts as a significant digit. And then this one is 400. This one only has 1 significant digit. These zeros are not considered significant here. And this one, because the 0 is to the right of the decimal, that one is significant, so that one would be 3. So you can check these on your examples. You should be able to follow along in your book to do this as well. All right, so let's look at how you can change a number into scientific notation. All right, so scientific notation is you want to write a number that's between 1 and 10 times 10 to some integer. All right, so you can see the first number they give us is the number 34.8. So if we need to write 34.8 as a number between 1 and 10, that means we have to slide the decimal to the left 1. So it's going to become 3.48 times 10 to the first power. All right, so all the digits remain, so the number has 1, 2, 3 significant digits. All right, in the next one, the number 0.05 becomes 5 times 10 to the negative 2. So you can see this moves to the right. The decimal place moves to the right 2 places to get this in scientific notation. So remember, this number has to be between 1 and 10. All right, so there are no zeros, and we are left with 1 significant digit. All right, the number 2,301 becomes 2.301. Again, the 0 remains, so the number has, this one would have 4 significant digits. All right, and then 400 becomes 4 times 10 squared. This one's only going to have 1 significant digit because the zeros kind of go to the power here. All right, this last one is a little bit more difficult, it says. So when we write 56.0 in scientific notation, we must leave the 0. This is because it's written after the decimal, indicating that it identifies a level of precision that is important. So the number becomes 5.60 times 10 to the first power. And that means there are 3 significant digits here. So we can check those and make sure that we got those correct. If you have any questions, please feel free to message me and I'll be happy to go through it with you. All right, on the next part, it says add and subtract. All right, so make sure you know the rule. When adding and subtracting measurements, your answer should not be more precise than your least precise measurement. All right, so example, you're adding measurements taken in class. The following measurements are taken. Student 1, 35.4 centimeters. Student 2, 405 centimeters. And student 3 is 1.2 centimeters. When we add these measurements together, we get 441.6. However, we notice that student 2 had the least precise measurement with 405. They rounded to a whole number instead of a decimal, or instead of the 10th place. Since this measurement is precise only to the nearest centimeter, we must round our answer to the whole centimeter. So we're going to round 441.6 to 442 centimeters. All right, a similar rule when we multiply and divide. Okay, your answer should not have more significant digits than the measurement with the fewest significant digits. All right, for example, if you are calculating the circumference of a circle, you know the radius of a circle is 5.0 centimeters. 2 pi r is how you calculate the circumference. So 2 pi times 5.0. So that's going to have 31.4159. So in the formula, 2 and pi are not measurements, so you do not need to consider them or how many significant digits there are. So a measurement is something you had to measure. We had to measure the radius, which is the 5.0. So that's the only number that we measured there. All right, since 5.0 has 2 significant digits, their circumference is 31, because you can see this is the number we got when we multiplied this, but since you only have to have 2 significant digits, we're going to round it to the whole number. So that becomes 31, since 31.4 would be rounded down. All right, so when you're talking about precision and accuracy in calculations, make sure you know that's the significant digits, or the number of significant digits, definitely plays a role in that. If you have any questions, please let me know.